Hey everyone, welcome back. Today's explainer is an absolute deep dive into a really fascinating, highly opinionated source text. We're looking at a piece that compares Tesla's core engineering philosophy with some broader, very different trends happening in the electric vehicle market right now. We are going to explore a perspective that heavily critiques competitors while praising deep engineering over surface-level aesthetics. It's a super provocative read, and our goal today is to impartially unpack the author's core arguments. We're going to examine exactly what they believe separates true technological innovation from mere marketing hype.
Okay, let's dive right into this. We're going to systematically unpack today's topic through 5 main pillars. First up, Tesla's battery technology. Second, size, efficiency, and safety. Third, EV market profit strategies. Fourth, the smart driving landscape. And finally, data versus driver claims.
Section 1. Tesla's battery technology. To really get what this source is arguing, we literally have to start at the absolute foundation, the physical battery itself. The text traces this really specific timeline of Tesla's battery evolution. Back in the early era, they relied on the 18650 cells. Then, that eventually matured into the 21700 cells, which are widely used and highly stable. But the author points to this next generation, the custom 4680 cells, as the true pinnacle of development. According to the text, these newer, much larger cells represent a massive leap in energy density and fast charging capabilities. But here's the catch. They were only made possible through incredibly intense, heavily focused R&D.
And this brilliantly illustrates how the author contrasts different battery philosophies. The text makes the case that cylindrical batteries, which is the type Tesla uses, have a fundamentally higher safety coefficient, meaning a much lower fire risk. The trade-off, though, they require incredibly complex software and hardware coordination just to manage heat dissipation. On the flip side, the author claims that pouch or prismatic batteries, which the text almost dismissively calls brick batteries, are commonly used by competitors in lower-end cars. Why? Well, they're easier to manage, but the source argues they come with a much higher risk of swelling and failure. Actually, the author asks pretty bluntly, in your day-to-day life, do you see more cylindrical batteries swelling up and exploding or soft-pack ones?
So moving specifically to that 4680 cell, the source really highlights the incredible manufacturing hurdles that had to be overcome. The author emphasizes step 1, this super difficult shift from a wet to a dry manufacturing process. And it wasn't just a tiny tweak either. It took a massive amount of time to perfect step 2, which is ensuring absolute consistency in mass production. And ultimately, hitting that consistency leads to step 3. Achieving lower costs right alongside much higher structural strength. The author's main point here is that doing the hard, expensive R&D internally ultimately creates a superior, safer, and cheaper product in the long run.
All right, Section 2, Size, Efficiency, and Safety. Here the source uses some pretty highly charged language to critique current EV design trends. They're specifically targeting markets that prioritize superficial face, status and prestige, over actual structural reality. Consumers might desire a car that looks imposing, maybe mimicking a massive Porsche or Land Rover. But the engineering reality? Those massive vehicles are incredibly heavy. To move all that weight, you need absolutely massive batteries, which the author argues just results in highly inefficient energy usage. Furthermore, while consumers perceive all that bulk as safety, the author claims the engineering reality of those oversized frames actually leads to poor durability. They highlight a high risk of broken axles, or as the text metaphorically puts it, sprained ankles.
The author actually sums up all this frustration with a very direct quote. Vehicle is large, battery must be large, efficiency ratio is garbage, they are all half deceiving and half selling. Wow, right? The source is directly accusing competitors of using aggressive sales tactics just to hide fundamentally poor energy efficiency from consumers who, just want a big, impressive-looking car.
That brings us to Section 3, EV market profit strategies.
Okay, zooming out from the physical car itself to the underlying business models, the source makes some seriously bold claims about how competitors are supposedly generating massive profits. According to the text, instead of pouring money into battery tech or structural safety, these competitors are just loading vehicles with superficial add-ons. We're literally talking about putting refrigerators, color televisions, and large plush sofas directly into the cars. Unless you're planning to make your EV your primary residence, the author aggressively critiques these features as total distractions from core automotive engineering. They're basically just designed to dazzle the buyer.
And here is why they do it. Massive markups. The source claims that a base vehicle worth roughly $100,000 can be marked up 2 to 3 times its actual value simply by adding these gimmicks. 3 times! The author likens this directly to certain high-margin, low R&D sectors of the smartphone market. Where companies take basic components, slap a big camera on it, and charge a premium without actually investing in foundational technology.
So, the crucial point is that the author boils all of this down to two completely contrasting business strategies. On one side, the argument is that Tesla utilizes a global volume strategy, very much like Apple. They source custom parts from major factories, leverage massive global volume to drive down costs, and provide really robust after-sales support. But on the other side, that's the assembly strategy used by competitors. The text describes this as copying designs, applying high markups, using those gimmicky TVs and sofas, contributing zero core R&D, and ultimately offering poor after-sales service.
Next up, Section 4, the smart driving landscape.
Shifting our focus over to software for a minute, the text frequently references FSD, or full self-driving. Just so we're all on the same page, in the context of this source, FSD refers to advanced driver assistance systems that rely heavily on incredibly complex localized data. But, as the author is quick to point out, the global adoption of this technology is highly uneven.
Which naturally brings us to a major question posed implicitly by the source. Why exactly is FSD technology facing such intense resistance in certain competitive markets? Think about it. If the technology really is superior, why isn't it just being universally welcomed?
Well, the author's theory here is deeply rooted in culture and economics. The source argues that competitors in certain regions are intentionally stalling the adoption of superior FSD tech. Why? Simply because of local pride and an absolute need to win at all costs. The author suggests these markets just cannot accept the loss of face that comes with admitting an outside technology is better, so they drag their feet. They use market protectionism to delay the inevitable, supposedly just waiting until they can no longer find gullible buyers for their own inferior systems.
And finally, Section 5, data versus driver claims.
Now, what's really interesting about this final part of the text is how the author views human psychology versus computer logic. When discussing accidents, the source completely dismisses human testimony outright. They describe human memory as emotional, abstract, totally prone to lying, and characterize it as just the left and right brain fighting. In stark contrast, the author views machine data as the absolute truth. The car's computer objectively records every single input, every pedal press, and every signal, with absolutely zero bias.
This leads the author to a very definitive, completely unapologetic conclusion regarding rumors of EV malfunctions. The text plainly states the machine is either right or wrong, so Tesla brake failure is impossible. Because the computer logs literally every single action, the author argues that a true, untraceable brake failure is simply a myth. It's born from human error and subjective, flawed testimony, not mechanical reality. Which leaves us with a pretty provocative final thought based on today's source material. In this rapidly evolving landscape of EVs, will consumers ultimately prioritize objective engineering data, efficiency, and real safety, or will the market just continue to reward the superficial narrative of status, massive screens, and imposing vehicle sizes? It's a huge tension that really defines the modern automotive industry right now. Thank you so much for joining me on this explainer, and I highly encourage you to keep questioning the technology behind the products we use every single day. See you next time.